I didn't want to do it in the lab because everybody has to stop working when they're filming, and I can't afford it.
Yeah.
And they complain, of course.
Why is there so much interest in interviewing?
Well, because there is being used so widely in the U.S. and so many states have approved it, and the same is happening in Europe. So when something which is not well known is being so widely used, people come out and start asking questions: how, where, what are the type of diseases that it can do, what is the scientific background, what are the side effects, and so on and so forth. So quite a lot of people come around and start asking questions.
Can I ask you both something? Do you feel like a weight? Do you feel a weight and a sort of a pressure to keep discovering things or to live up to your discoveries in a way?
I'm not sure that I think along those pathways. We've been doing, in the lab in Jerusalem, we've been working since 1964. Lumír, Dr. Hanuš worked in the Czech state a little bit later, and these were two individual separate researchers. Then Lumír joined our lab about 20 years ago. And no, I don't think that we have to find new things all the time. That's part of what we do all the time. I mean, we do things, some of them succeed and some of them don't. Sometimes we find new things and sometimes we don't. So it depends on what we're doing. You see, most people are interested in the plant, cannabidiol, THC in the plant, and so on. This is something that we did, and Lumír and the Czech researchers did it separately, I don't know, 30, 40 years ago. We did it about 50 years ago. Work on the plant, identification of the active compound. See, the active compound, THC, was only partially known when we started work on it. The structure was unknown. It was not available for research, and of course, that's a major problem. This is contrary to morphine, which had been isolated from opium 150 years previously, or cocaine, which had been isolated from coca leaves 100 years previously. And of course, they had been investigated thoroughly. Here we had a strange situation. That is a plant that's being widely used in various forms, marijuana, hashish, etc., etc. But the science behind it was rather weak because the active compound or compounds had never been isolated in pure form and they could not be investigated. So in the 60s, we went first into that direction, isolating the THC and many other compounds. And we re-isolated cannabidiol and quite a lot of other compounds, quite many of them new compounds that had never been isolated previously. We identified their structures, and then we started looking at the metabolism, the activity, and so on. And this went for quite a long time. This is essentially the first stage of cannabinoid research, work on the plant, chemistry, biology, clinical effects, and we did some clinical trials just as well. Now, this is something that we did in the 60s, early 70s. We did some clinical work, and I can tell you about it later. But that was the first stage. One thing that was not known at that point, how does it work? What's the mechanism of cannabinoid work? And it turned out that there are receptors, proteins in the brain and in the body, that THC binds to them. And these receptors, there are two of them. One, when activated, causes the well-known effects of marijuana, the high. The other one does not. Binding of THC to that particular receptor causes only protective actions and doesn't cause the high. So THC binds to both these receptors. Now, we don't have receptors in our body because there is a plant out there. We have receptors in our body because we produce compounds that activate these receptors when needed. So we went ahead looking for these compounds. At that time, a fellow who had worked on the receptors joined as a postdoctoral fellow, and Lumír Hanuš came from the Czech state as a visiting scientist, and then he has been here with us now for he came for 6 months 20 years ago, and he's still here, and he just retired. So
I don't think he retired. I think he's completely an entrepreneur now.
Yeah, that's something else. You see, retired from the university.
You must retire.
The university, one has to retire at the age of 68 or something like that. So we went ahead looking for the compounds that our body produces that activate these receptors. So we believe, I see it as the second stage of cannabinoid research. The second stage meaning not the compounds from the plant, the compounds that we produce that activate these receptors and cause a lot of effects. And indeed we worked, and at that time, as I said, Dr. Hanuš had joined us, and Dr. Devane had joined us, and quite a few others, and this was in collaboration with several groups abroad. The compounds that we were discovering were also tested in the UK and tested in the US, and we found eventually 2 compounds that our body produces. Chemically, they're completely different from the compound that the plant produces, but they have the same activity, more or less. So we called one of them Anandamide, and the other one 2-AG. Ananda in Sanskrit, of course you know Sanskrit.
I speak it every day.
Yes. So we found that Ananda is supreme joy. Anyway, we called the compound Anandamide, and we elucidated its structure and synthesized it, and the same with the second compound, 2-AG. And these 2 compounds are present in the body, made by the body when and where needed. And they act when and where needed. For example, if somebody has been injured and there is pain, the body will produce anandamide and 2-AG in that area in order to lower the pain. But they are involved in a huge number of additional actions in the brain. As a matter of fact, researchers at NIH, National Institute of Health in the US, had a review, and they said these 2 compounds, as a matter of fact, the whole system of endocannabinoid system, the receptors, the compounds, and so on, are involved in essentially all human diseases. This is a very strong statement, but they are because they do several things. They regulate some of the other neurotransmitters in the body, and they have actions of their own. So they are extremely important, and therefore there has been a huge amount of work on them. Thousands of papers have been published on anandamide and 2-AG, and we know quite a lot about their activity within the body. So we see that as the second stage of cannabinoid research, showing how this endogenous cannabinoid system works in the mammalian body, in our body, and how it is associated with everyday life, mood, happiness, sorrow, and so on, and with disease states.
Is it sort of like a part of the immune system somehow?
Well, it is parallel to the immune system. The immune system guards us against all kinds of things happening to us. Without the immune system, we'll be dead within 24 hours. The activation of one of the receptors, it's called the CB2 receptor, activation of one of the receptors helps.
Close this for a moment because it's noisy. Can I close this?
Basically, activation of the endocannabinoid system of the CB2 receptor is apparently extremely important in guarding us against all kinds of things that are happening in the body, and we want to prevent them. We don't know enough about it, but we know quite a bit, and we have seen that in many diseases, activation of CB2 is important. It does not completely parallel the immune system. Maybe it adds to the immune system. And at some point we shall know, I hope, much better how these two systems work together.
For someone who gets interviewed twice a week about this, you seem very, very energetic.
Well, I have to be at my age, but but now we have moved to the third stage of the cannabinoid research, and there are very few people interested in that stage at the moment. And I can tell you in a few words what's going on. The endogenous cannabinoids we have in the body are formed are not very complicated compounds. They are formed from fatty acids, like oleic acid, which is present in olive oil, and amino acids, which form the proteins in the body. So here we have a simple, relatively simple compound. But the body has prepared almost 100 of these, maybe more, of compounds of the same type, fatty acids bound to amino acids. And it doesn't make 100 compounds because it has nothing to do. It makes them because of it knows how to make them, and it needs them. And we have found that these compounds, about 100 of them, those that we have investigated, are of major importance in our body. So this is the third stage of cannabinoid research. We found that one of the compounds acts in osteoporosis, the breaking down of bones. The background of that, women after the age of 50, with all the changes that are happening in the hormone levels, then they should have a lot of bone damage, osteoporosis. Not all women have that. And the reason is women, as well as men, but women in this case, produce a compound which is closely related to the endocannabinoids, closely related to anandamide, which blocks osteoporosis. In another field, with Professor Shohami, we found that compounds of this type affect brain damage. And if somebody has brain damage, the brain starts producing them and lowers the brain damage.
Wait, but if someone with osteoporosis creates these compounds, then how come they still have osteoporosis?
Well, they do not block completely. They act against the osteoporosis. The body starts breaking down the bone. See, our bones are not stable in the sense that the same bones that you had when you were 6 years old will be when you're 6 years old. The body changes them. I mean, breaks them down and builds them again. Breaks them down and builds them again. There are cells that build the bones and cells that break the bones. So these compounds, endogenous compounds, limit the action of the cells that break the bones and enhance the action of the cells that build the bones. So it's a regulator in this case. The same is true for brain damage. We recently found something else which is also of major importance, I believe. We have to find out. Our body makes one compound of that type that tries to block certain addictions. In this case, we have worked only in nicotine addiction. We found that our body makes a compound that tries to block nicotine addiction and tries to block the effects that are caused by addiction, the effect that caused after one stops taking an addictive drug. Now, it doesn't succeed always, but sometimes apparently it does succeed. Most of the research on addiction has been done on the addicted people or addicted animals. Very little work has been done on those that are not addicted. We have, with different addictive drugs, only partial addiction, only depends on the drug. It may be 20%, 60%, 70% get addicted. Why don't the other get addicted? Why don't we have? Because the body produces a compound and maybe compounds. We so far identified one compound and published it, showing that it blocks nicotine addiction and it can block the withdrawal effects, both of nicotine and of opiates in animals. We haven't tested that in humans. That's complete. That's the next phase. So if the body does that, it's a major advance towards using such compounds as anti-addictive compounds. So here we are at the third stage of cannabinoid research, working on compounds that are somewhat related to the endogenous cannabinoids, but have a huge effects in many other medical situations.
Are you okay over there with the shoulder? So if I want to ask you a few things about different things. Do you feel if you haven't discovered THC and if Lumír hadn't discovered Anandamide, would someone else have discovered it?
Oh yes. I mean, it's nice to think that we are the only geniuses in the world, but no, it doesn't work that way. Science advances. People are happy to make an important step, but chances are that if we hadn't done it, somebody else would have done it.
Even with cannabis, that's so it's rare. It was rare for many years for anyone to study it. Do you think we would be very far behind if you guys didn't?
Well, we have contributed, yes, definitely, but science moves ahead. It's based on individuals, but science moves ahead, and chances are that if we had not discovered or identified the structure of THC, of cannabidiol, somebody else would have done it, maybe a few years later. Maybe the things we did pushed the whole field ahead, but chances are it would have been done by somebody else. The discovery of anandamide and 2-AG, again, chances are that it could have been discovered later. As regards the third stage, who knows?
That guy, I can't remember his name, Gil, I think. I can't remember. The guy who runs Dedi Meiri's lab with him told me that when they first opened the lab, the Technion was against it. And they said, okay, we'll let you open it, but they were embarrassed by it or something. And
I'm not so sure about it. They got a lot of money. They got millions in order to set up the lab.
Yeah, but
so
what I mean is that he said that when people came to visit the Technion, they wouldn't come to show them the lab. And so what I'm getting at is, do you think is there a sense of, is there a fear of the establishment in studying cannabis?
Not at the Hebrew University. As a matter of fact, when I moved here in 1965, they asked me to move over after I was at the Weizmann Institute, and here they offered, they suggested I should set up a independent unit, which I did, and the university never had any objections to what we were doing. As a matter of fact, the professors at the university didn't look at it as something that, well, maybe should not be done. And the fact is that I was well accepted personally, and my research was well accepted. And many years ago, I was elected by the professors, by the Senate of the university, to head the university as academic head of the university, as rector. If they thought that we're working on something that is, well, objectionable, they wouldn't have done that. So it's a positive sign.
Why did they not think that you were working on something objectionable? It was illegal in Israel, just like everywhere else. So why was it acceptable, do you think? Why was it okay?
Well, it's illegal to use. It's not illegal to do research. I mean, people do research on illegal things. Most of the investigations in law have to do with breaking the law. Who knows what? No, there are two different things. We were not doing anything illegal. As a matter of fact, our work was supported originally not by financially by giving us, without having to pay anything. We got cannabis from the police. The original work was done by quite a lot of cannabis that I got from the police. I never had any problems with the Ministry of Health. As a matter of fact, they consulted me. I never had any problems with the National Institute of Health in the US. As a matter of fact, I was given an award by the National Institute of Health for our work on cannabis. And
it's very different in America.
Well, no, but I got the award in America.
No, I mean,
for our
there
research.
They can't do this research for the way you
Well, the laws are complicated there, more complicated than here. I mean, people have to get all kinds of approvals. The same is here, but here we're a small country, and I have no problems getting the approvals. The Ministry of Health actually sometimes have some of my students there. We've never had any problems getting approvals as long as we did our work legally. And we always did our work completely legally. We never had any legal problems.
Why is it worth studying cannabis?
One second.
Why should we bother?
Well, we bother because it's something of importance, but in a university, this is a little bit strange to ask why. You see, something exists. We know that cannabis, it has been known for thousands of years, that cannabis has two types of effects. It causes what we call the high today, but it also has medicinal effects. We should study that. We should know why cannabis does that. Are there different compounds that cause the recreational effect versus the medicinal effect? We should learn about all kinds of things. Academics try to work on things that are, in their eyes, important, not necessarily important to the community in general. They have to decide, and sometimes it turns out that academics find things that later on turn out to be of major importance. I can give you numerous examples of that. Breaking the atom. Who cared about the atom being broken down? It's a nice thing. Well, it did matter because it is the basis of atomic energy and, unfortunately, atomic bombs and so on. There are many other things. Who cares about a certain place in the brain? Who cares? Well, we do care. So we try, I mean, individually. We're not told from above. That's the major difference. Academic, a professor at the university, decides on his own what he wants to do research on. He's not being told from the top, do research on this one. He has to decide on his own, and this is the best way of doing it. And this is why universities in the West, in Europe, in the US, obviously in England, Germany, France, so on, has advanced much more than in many other countries, because there the individual decides what he has to do, not somebody who is on the top and decides for everybody else.
Do you think, when you're working in front of a microscope, do you think about greater context, about societal context at all, or do you just look for what you're looking for?
Well, Louis Pasteur in the 19th century said that chance helps the prepared mind. So you look for something, you have a plan, you look for something, but if you know a little bit more, you know what's going on, and you see something happening, then chances are you can explain something new. So new things happen. Sometimes these new things are of major importance, but in most cases, these new things can be observed by people that have the background to understand what's happening.
What I mean is, I meant something different. Do you when you're doing science research in a room in a lab, do you think about the connection between this research and all of society using this research later, or do you not think that way?
Well, this is exactly what I told you. Society is something very large. I mean, a scientist is not thinking of society every minute. Maybe in the evening when he looks at his results as well, maybe society will be interested and so on. But he has a plan, he has to work. Maybe his work will prevent some kind of disease. Maybe the work we are doing on addiction will prevent or slow down addiction in many cases. In the US, last year there were, that's what I read, 65,000 people died of opiate addiction, mostly opiate addiction in the States. Well, maybe by helping with the withdrawal symptoms, we can help that. If we can block the withdrawal symptoms, then many people will be able to get out of their addiction. At the moment, many of them are afraid of the withdrawal symptoms, so they continue taking the opiates in order not to get withdrawal symptoms. It's a simplified way of telling it, but it has something to do with it. Or when we looked at cannabis, well, we knew that a large number of people are using cannabis. Maybe we can learn something about it. And we have learned not only about the recreational effects, we have learned something about the medical effects. And I believe that within the next decade or so, we shall have quite a few cannabinoid-based drugs on the market in various fields. Let me give you a few examples.
Yeah.
We work on cannabidiol, a major compound found in cannabis, which is not psychoactive, it doesn't cause the high. And people would have thought, okay, so it's not of major interest. It is of major interest because cannabidiol is a major possible drug. We have seen that in epilepsy, it blocks epileptic attacks. We published that 35 years ago. Cannabidiol blocked epileptic attacks in patients that nothing else was helping them. What happened? Nothing for 30 years. Just the neurologists were not very interested. Nobody was very interested until parents found out that plants that contain a lot of cannabidiol, maybe they saw our work or maybe they just learned it from other sources, they found that cannabidiol helps children with epilepsy. There are children that have 20, 30 attacks a day. Well, cannabidiol helps them. So our work on the prevention of epileptic attacks by cannabidiol is an important medical step forward. Now, about 150 children in Israel are getting extracts with a huge amount of cannabidiol that blocks their epileptic attacks. So these children would not normally will not be able to develop with 20 attacks a day. Now they are more or less normal. In the US, a major study was done based on what we did 35 years ago. Yes, they showed that it's of major importance in epilepsy. So here we have a medical advance based on the basic science on identifying cannabidiol, looking at cannabidiol in animals, finding out that it's anti-epileptic, then going into humans. It doesn't always work that way. We showed that in diabetes type 1, which is an autoimmune disease, cannabidiol is of major help. Well, nobody has done that in the humans, which is a shame, because it helps in animals, exactly the same mechanism. It helps with diabetes type 1. Why it has not been tested in humans, it's beyond me. It costs a lot of money to do clinical trials. But I have no doubt that when tested in humans, it will show the same effect. Cannabidiol has been shown to be an excellent anti-schizophrenic drug in schizophrenic patients. Now, schizophrenia is not a minor disease. 1% of the population in every country has schizophrenia. So we're dealing with millions. And there are drugs against schizophrenia, but they cause side effects. Cannabidiol does not cause side effects. And once it is pushed forward, chances are that it will become a major anti-schizophrenic drugs. So we see a lot about autoimmune diseases, namely diseases in which the body attacks itself. Why the body attacks itself is a complicated question. We, in most cases, don't know much about it. But in essentially all autoimmune diseases that have been tested in animals, we see that cannabidiol helps. So the basic work that was done on cannabidiol may turn out to be of major importance in medicine.
What can you tell me about the original science about the anti-epileptic stuff? Was that done here?
Well, it was known that cannabis is an anti-epileptic agent. As a matter of fact, there are all kinds of individual reports over hundreds of years, on and off. And I like to quote somebody in the Muslim world, a major person in the Muslim world in the 15th century. He had epilepsy, and somebody brought him cannabis, and he didn't have epileptic attacks, but he had to continue taking the drug. This was actually written and described in the 15th century, and the document was found about 20 years ago in Paris by a friend of mine, Dr. Rosenthal, who worked at Yale. So here we're doing we have information of the 15th century, and most probably it was also used for the same purpose in India to a certain extent, India, China, and so on. So when we started work, we had some individual information, but today individual information is not enough. One needs information on humans, one needs a scientific medical way of doing it. We need people that take placebo, namely take the same solvent or the same drug without the active compound, and those that take the active compound, and who is doing the research should not know who is taking the placebo and who is taking the active compound. At the end of the research, one should do that. So we started working on that. We always work in collaboration. We collaborate with friends and colleagues all over the world. In this case, it was with a group in Sao Paulo in Brazil, and we first tested cannabidiol. We isolated huge amounts of cannabidiol from cannabis given to us by the police, and we sent them almost half a kilo of cannabidiol. They first tested it in animals, animals with epilepsy. It worked very well. They tested, and then they went into human patients, and they looked at the human patients for several months. So here is how it is done. It has to be done in collaboration between chemists, in this case our group, biologists, in that case the work in Sao Paulo,
and the police.
And the police that gave us the material. So it has to be done in collaboration. It has to be obviously completely legal, and it has to be well planned ahead. And we've been doing that in collaboration with many other groups. The research on addiction is done jointly in collaboration by 4 groups, 4 independent groups. I mean, every one of them can say, I don't want to do it. Well, they do, because it's interesting. The addiction is done in collaboration by our group, a group in Richmond, Virginia, a group in Canada, and a group in Italy. So we work together, we correspond, we tell each other what's going on, and each one of us has his own specialty, and it can help the others who have some other specialty. So we do the chemistry and the general background, the general idea of cannabinoids. The people at Richmond work on nicotine addiction and so on. The people in Canada worked on opiate addiction, and the people in Italy work on addiction to food, actually, overeating and so on, obesity, things of that sort.
I've heard very interesting things about clinical trials. Some doctors have told me and researchers told me that they think clinical trials might need to be adjusted or even reinvented, rethought of, because for cannabis-based medicine, because its effect seems to be so individual. Dedi Meili and someone else said they completely disagree with that it has to stay exactly the same. I think Moshe Hod also did stay exactly the same, and that they have to do just isolates, and build up a pharmacology of which cannabinoids work together for what. What do you think about that?
Well, you have good research and you have bad research. If you don't do it the right way, it's bad research, and the results are not worthwhile. But today, advancing in the chemical medical side has to be done by good research of originally in animals and then in humans. The clinical trials have to be done according to rules that are well accepted by clinicians. Now, if somebody does a lousy research, well, it's a lousy research. But the good research is good research. One has to look at the research as it is done. Without clinical trials, today a compound cannot become a drug.
But do for cannabis medicine, can we do clinical trials the exact same way we do it for other medicines? Same methods?
Yes, one can take a compound, cannabidiol, and give it to schizophrenics. Take the same solution that contains the cannabidiol, but does not contain the cannabidiol itself, only the solvents and all the formulation there, and give it to other patients as the placebo. These are basic rules, and for example, the German group that published on cannabidiol in schizophrenia did an excellent job. So the work that was just completed in the US on epilepsy, a large number of epileptic children, it was an outstanding research proposal. It had to be approved by many other clinicians. It costs, unfortunately, millions to do it, but once it's well done, it should be well accepted. Clinicians have to base their work, their day-to-day work, on clinical trials. And these clinical trials have to be outstanding.
Can you do clinical trials with stuff that's not just isolated compounds, like with full spectrum plants?
Well, it is more difficult because it's doing it with a single compound. One can say what are the amounts of the single compounds, how often, how it has to be given, and so on. When a clinical trial is done with an extract, then one has a problem because the extracts can differ. So I assume that the people you talked to and were negative thought about extracts and not about well-defined compounds. This is true. Working with extracts may be very complicated, and this is because of something that we discovered many years ago, which is called the entourage effect. The entourage effect means that there are compounds in cannabis that modify the activity of THC. They by themselves have no activity, but they modify the activity of THC. So if you have different compounds every time you do a clinical trial, or an animal trial as a matter of fact, with an extract which is not exactly the extract you had previously or somebody else had previously, then obviously you cannot compare because of the entourage effect.
So is that a barrier for research? How do you overcome that?
Well, you work with well-defined material.
So about isolate and full spectrum, there are people who have told me very, very confidently and adamantly that isolates are not helpful. But I've definitely heard the opposite. I've heard isolates can be very helpful. some people are saying only full spectrum is helpful, and you have to have THC to make the CBD become, useful. What do you think about that?
These are very general statements. You have to go into very specific cases. Pure cannabidiol is outstanding in many diseases. There are a lot of people that claim that one has to use extracts in order to get better effects. Maybe in some cases this is correct, but in order to do a clinical trial, one has to do it with well-defined extracts. So this is where we stand.
Do you think so? Is pure cannabidiol useful in many indications that you've seen so far?
Yes, as I said, we did work on epilepsy with 100% cannabidiol, pure, crystalline. The people in Germany did work on schizophrenia with 100% pure cannabidiol. The work in epilepsy in the States, the clinical trial, was done with compound which was almost pure CBD extracted from the plant. And the reason they did it is because an extract from a plant falls under different legal definition in the States. A pure compound has, that's what I understand, I'm not a legal person, a compound that is pure falls under jurisdiction of the FDA. Extract of a plant is something else, so it's easier to do.
Yeah, if the extract falls under the DEA, it's illegal.
Well, the extract, you see, plant extracts in the States are seen legally in a different way. So you have a $50 billion business of extracts, various plant extracts in the state, and the FDA has essentially, it cannot say anything about them. This is not the same as pure drugs, pure compounds. The FDA has a lot to say about them. So legally, two different legal situations.
What do we know about cannabis in pregnancy and in birth and in women's health in general? And its effect on the mother and the fetus?
Well, most women that still take cannabis say that nothing major has happened. For some time it's thought that the children that are born may be smaller and develop more or less normally. But basically, I would strongly recommend not to use anything during pregnancy, not cannabis or not any drug if possible, because it's extremely difficult to know exactly what's going on. If you have a drug which causes damage to the fetus in 50% of the cases, this will be seen immediately. But what happens if the damage is seen only in one fetus out of 1,000? It is not seen in any clinical trial, but the one damage is one damage. That particular damaged baby is damaged. And we don't know. It's extremely difficult to prove anything of that sort. I mean, we need statistical proofs. It is very difficult to work with effects that, with things that affect, I don't know, 0.5% of the population or 0.5% of the fetuses. And what I would normally suggest, if a pregnant woman asks me, may I take cannabis because it lowers the vomiting I have during the pregnancy, I say, well, too bad. Just suffer the vomiting and don't take anything, any drug.
But isn't that true for any disease that anyone has? Because you can say, well, we we haven't checked it on 10,000 people yet, so maybe it will do damage, even though it helps many people.
Well, this is probably true for all kinds of minor effects, but there we know that in a disease it helps the disease. Pregnancy is not a disease. Pregnancy is a normal thing.
So are there any things that you would have done just since 1964 was the THC isolation, right? So since then, is there anything you would have done differently that you think would have changed in any way the way that the industry, I'm calling it, has gone?
Well, scientifically, probably not. Probably I could have got more money to do more research, but basically we went the right way. What I should have done better is try to get industrial interest, and still, although we know that these compounds have activity, cannabidiol, derivatives cannabidiol, they are still not sold as defined drugs, and possibly I could have pushed more for that. For example, Teva, the biggest company in this in Israel, the biggest pharmaceutical company, is not really interested. Was not interested. Chances are that we could have pushed more for that, but we didn't.
Yeah. So, but scientifically, you feel like everything was done the right way.
Well, maybe it could have been done faster. Maybe the group could have been larger. We always had, my group was always a small group of 3 or 4 people working in different aspects. No, I can't say. Most of the work we do is collaboration. We do a lot of collaboration with many other groups. In research that is done between chemistry and biology, one needs good collaboration between the chemists and the biologists. And over the last 30, 40 years, we have always had collaborators in various fields. And every aspect, anything that we do now, is always in collaboration with people that are well informed, know how to do the biology or the clinical work and so on.
Lumír, do you think there's anything that it should have been done differently over the years with cannabis research?
I see the biggest problem in cannabis research cooperation between different nations, scientists from different countries. Because cannabis is stigmatized and it's illegal drug, just to exchange of samples is big problem. So samples sometimes are analyzed locally and we cannot compare with samples in abroad. So we can do locally even different studies, but it's problem to do it in the other country. Because when I ask one of my friend in United States for some cannabis standards, he told me, you know, this permits export, import, it's such complicated. Better come to here and do it here. It will be without any problems. Yeah. So I see this is a certain break, you know.
Yeah.
But
do you feel like if people rolled their eyes at you over the years and did you feel stigmatized over the years from people? Did people look down at any of you for the research that you're doing? Other scientists, do they ever say, "Oh, those are the guys that do marijuana"? You know.
Not in my case. I can't complain. I've the fact is that I've been given prizes all over the world in many countries. I have honorary doctorates from the U.S. and Canada.
But on the day-to-day level, you know, from people that you meet, is it always like a joke to other people or people who don't understand?
No, as a matter of fact, most people think that it's important to do. If somebody thinks otherwise, we are an open country. Let him think otherwise.
How about you?
I did research in United States, in Czechoslovakia, in Israel. I never have problems. We cooperated also with criminalists. Was no problem on medicinal level on medal as a drug of abuse. So I cannot complain. Just only this relations international, you know. This is a little bit problem because of legality.
Yes.
Let me give you an example of what Lumír is saying. I collaborate with a group in the UK, a well-established group in the UK. The person that heads that group has a knighthood, he's Sir, and so on. But I cannot send him the derivatives of cannabidiol because of legal problems in the UK. They don't. He was head of a major group at Oxford. He's not somebody who is on the side. He's at the center of British research, highly regarded, and yet I cannot send him the compounds because of legal problems. Pity.
Ridiculous.
Yes, it is ridiculous. Because they're not giving them to humans, they're going to test these compounds in the test tube, and they're going to test these compounds in animals. And if they are good drugs, then they have to go through the official legal things in order to get into the humans. But nobody says that he's doing anything illegal, on the contrary.
Wasn't it frustrating to work for years with this stuff that's completely illegal outside? I understand you have to study things that are illegal, but is it frustrating because you're discovering, hey, it works for epilepsy, but we can't give it to anyone because it's illegal?
C'est la vie.
Were you ever ready to give up because of that?
No, why should I?
Did you ever feel frustrated?
Look, concerning research, I was every time very satisfied. It was every time wonderful. We can share our ideas on paper, on emails. It's no problem. Only what's mentioned Professor Mechoulam. Just to send samples, it's complicated. What I told you that my friend told me, just come, it's no problem. So as you can see, he wrote me, come, it's no problem, but send it. It's complicated. Even I think if I want to bring some samples from the other lab here, I need certain permit, because I cannot take it and go by car and have the sample. I need to have sample with permit, because if stop me some police and they say that I have some sample from cannabis and I don't have permit with me, it can be problem.
Yeah.
Never happened to me, but theoretically I'm talking about it.
So there was where do you see this going in terms of how do you see this getting cannabinoid medicine getting into the into pharmaceutical drugs? How do you see that process happening?
Well, things are changing. Israel, as a matter of fact, is pretty well ahead of many other countries. Medical cannabis can be administered here. One needs an approval by the ministry or by physicians that that are associated with the ministry. There are about 35,000 patients that have approval, which is a huge number, for well-defined diseases, particularly in diseases that are not associated with psychiatry, almost everything else. In order to work with cannabis, a group has to get approval by the ministry, and there is a committee, a major committee that sits every 3 months, and it so happens that I'm chairman of the committee. So I collaborate with the ministry, and we are very liberal in allowing people to do research in cannabis. If somebody wants to do research in his backyard, well, we'll say no, because that's a way just to make legal cannabis into illegal cannabis. But if it's done in a university or a well-established unit, government or a company, then they have no problem doing research. And today there are, I don't know, probably 50, 60 labs in this country that do research in cannabis and various aspects of cannabis.
Did you ever expect that when you were starting out that cannabis and marijuana will become your life's work?
Well, this is one of the topics we've worked on. I am a natural products chemist. I work on the chemistry of natural products. On the chemistry, plants produce a lot of compounds. Contrary to humans, so mammalians, all of us produce the same type of compounds. We produce the same type of compounds, more or less, like a cow or a duck or a pig. Not with the plants, because we have an immune system. Plants don't have a specific immune system. Their immune system is based to a large extent on compound they produce, and every plant family has more or less the same type of compounds. But there are many families, and therefore there are thousands of compounds in the plants. So this is a well-established field of chemistry of natural products. If you look at a plant of one type, plant of another type, we find many different types of compounds, and most of these compounds, their structures are unknown or their activities unknown. So my group has worked for the last 50 years on the chemistry and biology of natural products.
And are you optimistic about where it's all going?
Well, I don't think about optimistic or pessimistic. We want to establish things. Hopefully, they will turn out to be positive in the sense that they can be used further on, but that doesn't depend on an academic lab where we can't do much about it. We can investigate something, we can show that something is happening, we can talk to the people that are involved in promoting a compound, but we can't go further on. The clinical trials today, contrary to what was in the past, cost a lot of money. I'll give you an example. When 100 years ago, insulin was discovered, and insulin is the compound that our body makes in order to regulate the sugars in our body. It was used immediately as a drug. It's an excellent drug, still being used in one way or another, the insulin. Anandamide, which we discovered 25 years ago, has never been given to a human, never. Insulin was given within 6 months. Anandamide probably is a pretty good drug, but it has never been given to a human because a company has to be interested and has to spend many millions of dollars to develop. So,
are you surprised when you look around and see just how big this is becoming, on how accepted this is becoming, and how much research there is relative to when you were just?
Well, I'm delighted. I'm delighted that the medical part of it is developing slowly, but it is developing. One should separate the medical use from the recreational use. The medical use has to go according to well-established medical routes. It has to go through toxicity and animals and then into the humans. It has, in order to be accepted by the physicians, it has to follow the well-established medical rules. Recreational use is a social issue. Recreational use has to be decided by the population. Whether it's toxic or not, that's something else. Obviously, populations all over the world have decided 100 to 200 years ago that smoking tobacco is fine. The fact that people die out of smoking tobacco doesn't matter. It has been socially accepted. The same is true for, let's say, whiskey, 50% alcohol. Definitely not very healthy, but it is approved. But this is a social issue. One cannot come over and say, we should be allowed to use cannabis recreationally because it helps with epilepsy. What's the logic there? There is no logic. These two things should be completely separated. One is a medical issue, the other is a social issue.
I was going to ask you before about anandamide. It's really interesting that we think of cannabis medicine as cannabinoid based, but we don't ever think about it as endocannabinoid based.
It will be 10 years from now.
Should it be?
Of course.
Why?
Because these are compounds that we make. If our body makes a compound, it makes it for a certain reason. And we more or less know what the reasons are. And there is no doubt that at some point people will start using it. Let me give you an example from a different field. There is a compound in our body called dopamine. And there is a major dopaminergic system. Well, it was known, but it was slowly discovered that the lack of dopamine causes one disease, and too much dopamine causes another disease. Too much causes schizophrenia. So in order to block, if there isn't enough, in Parkinson's disease, for example, one gives dopaminergic type compound to the body. If there is schizophrenia, one tries to lower that. So the body has to have a certain amount of dopamine, not too much and not too little. The same is probably true for anandamide. People have come out and claiming, without any major proof, that migraine, for example, is due to maybe lack of anandamide. Maybe. But of course it's very difficult to do work on migraine, because if you ask a mouse, do you have migraine, it doesn't want to answer you. But basically it seems to be, maybe it's true, so it has to be investigated. If in many of these diseases we find that anandamide or 2-AG, the two endogenous cannabinoids, there is too much of them or too little of them, maybe we can do something about it.
So can endocannabinoid based diseases that are related to the endocannabinoid system be thought of as a nourishment issue? Like, in other words, that if we're not making enough endocannabinoids, we need cannabinoid nourishment for some reason?
Well, possibly. I mean, this is still being investigated. But the fact that the endocannabinoid system is involved in a huge number of diseases, then obviously we have to think along those lines.
Okay, I think I asked you everything I wanted to ask you.
You're most welcome in that case.
Thank you. I was hoping to have you guys talk about something or other about research, but I don't really know about what, because this was an idea.
Well, if you want a second or two, we can talk.
I would love that. You can
now,
speak in English.
Do you see any difference between the attitude in the Czech state, which you know very well, previously, communist time or a bit later, and the attitude today?
It's a really big paradox, because in communistic regime everything was prohibited. It was not such easy. And we work on cannabis. In the fact, I started to work in 1970. By the way, the first name when I came to Professor Krejci, the first name which I was familiar with was Professor Raphael Mechoulam. This was even at that time leading authority, and this was the main brain concern in cannabinoid research. So this was first what I met. But in Czechoslovakia, Professor Krejci, he started to work on cannabis in 1950 when he discovered antibiotic principle. So we started to use it in medicine, and it was used up to 1990, when I left for 1 year to Israel, what is 28 years ago. So it became illegal. Even then, from 1961, it was illegal drug. We use it without any problem for treatment of patients in hospital. I prepared extracts 20 years to the drugstore, and they prepared medicine for hospital. without any problem. We cultivated cannabis without fence. I never lost one leaf. If we cultivate it on the same spot today, overnight there will be no cannabis. And before, patients were treated without any problem. Today, cannabis is legal in Czech Republic 5 years, and they use only 5 kilograms in 5 years. In the fact, it's not accessible for patients, and something like sativets, which is allowed, it's not accessible because it's more expensive than is pension of old ill person. So I see certain problem here because illegality became like harder pressure on that than before, and today situation is worse in Czech
But
Republic.
you are associated, I know that you travel to a lot of East European countries. You have been in almost all the small countries in Eastern Europe. And what's the situation there?
The best situation is today, we had several seminars in Macedonia. Today in Macedonia, cannabis for treatment is legal since last year. The most medicinal compound is considered THC. It's strange that CBD is not considered like medicine, like this is considered like supportive compound. Main is THC, so there can be extracts without any limit of THC contents in the sample. I was many times in Slovenia, even we had seminar in parliament. It's still illegal. The same in Serbia, in Croatia, where we had seminars several times. It's still illegal, just only Macedonia. Better situation maybe is in Austria, because there they sell CBD extracts like 5%, 10% CBD. You can buy it without any problem. It's legal. In Czechoslovakia, I said it was used for treatment. Today in Slovakia, what is separate country today, everything is illegal. Cannabis, CBD, everything is illegal, like in the United States. So situation between Czech Republic and Slovak Republic is quite different. And in Czechoslovakia, mainly cannabis was cultivated in Slovakia. So today...
Well, in the US, of course, things are different because you have one state that cannabidiol can be freely sold and so on, another one when it's illegal. So if you have 1 gram of cannabidiol in your pocket on this side of the border, state border, not country border, state border, you're fine. You just walk at 10 meters so past the frontier, then you can go to prison for 5 years. So
the same is
that doesn't make much sense,
Yes.
but that's the situation.
The same is with alcohol. When I was in the United States, there was county where I was, it was prohibited to buy alcohol, but 1 meter after the border of this county was liquor store and you can buy it.
So chances are that things will change within the next couple of years. We shall have most probably plant material, basically cannabidiol and derivatives, which come from the plant, but companies will develop derivatives, and derivatives will be sold. You see, the natural products are not always sold because of various reasons. Let's look at penicillin. You cannot buy penicillin in the drugstore. Penicillin is not available as a drug. You have derivatives of penicillin. Chances are that we shall have the same with cannabis, but because of the wide use of plant cannabis, you will have plant cannabis sold for many years, and you will also have derivatives of mostly cannabidiol, and there you are. So you'll have 2 different types of drugs.
In fact, we need a lot of experimental studies and trials, clinical trials, because up to now, when were prepared derivatives of cannabis, it was like successful, but at the end it was not successful. Yes, only I think Nabilon is used, but not the other one. Except of that, I use just cannabis extracts like dronabinol, marinol, this is THC, or epidiolex, what is CBD. But others like was one derivative for obesity, and then patients were depressed, even commit suicide. So it's not such easy to prepare derivative. It's very, we cannot do it at the university. This can do only rich pharmaceutical companies. And chance is about 5%, and they must spend tens of millions of dollars for it. So it's not also such easy for pharmaceutical companies.
Well, I hope it will change. We, as you well know, we work now with 3 or 4 companies in different aspects, and they're spending their money in order to advance cannabinoid research and to advance cannabinoid drugs ultimately. Hopefully, they will succeed.
I hope also, because you had, from the time when I came to the university and I heard your name for the first time, you had so many wonderful ideas, and some of them up to now were not fulfilled because of illegality.
Yeah. Well, so there we are.
I hope that you didn't tell us the last word. Still, I am sure that your contributions will be wonderful, and that
thank you.
It will help to the patients.
Wait, what kind of ideas that have not been fulfilled?
Well, the development of many of the synthetic compounds, which are known to be pretty good in animals, they have not advanced to clinical trials. As a matter of fact, the schizophrenia trial, which was done obviously in human patients and so on, has not advanced cannabidiol to be accepted as an anti-schizophrenic drug, which is very strange, but that's what's going on. Chances are that derivatives will be better accepted. We have made derivatives of cannabidiol which are better than cannabidiol itself. So chances are that sometime within the next decade, who knows, cannabinoid drugs will be on the market and will be widely used.
What's a derivative?
Well, we have published, for example, cannabidiol with a fluorine atom on the cannabidiol molecule. So it's a fluorocannabidiol. We have published that. In collaboration with a group in South America, we have shown that it is pretty good in anxiety, lowering anxiety, pretty good in acting on other psychiatric diseases. We have shown that cannabidiol itself is pretty good in these things. We have recently shown that another derivative, which is a derivative of the acid of cannabidiol, helps with depression. So chances are that at some point some of these compounds will become major drugs. You see, depression and anxiety, for example, are major diseases in Western society. Huge percentages of the population have anxiety or depression on and off. And we need compounds that do not cause side effects. We need simple compounds, or compounds that are, one doesn't have to be anxious taking the compounds against anxiety.
What is the role of anecdotal evidence in this research?
Well, anecdotal is, according to the work, anecdotal. I mean, you have a person in Paraguay, who knows where, saying that it helps against a certain disease that he has, which is, well, academic person will say that's an interesting observation, but until we have a clinical trial, it's just anecdotal. I mean, well, maybe this person by chance was getting better anyway, and he took the drug, and well, maybe the drug has nothing to do with he's getting better. We have to have well-established clinical trials.
But is there a moment where anecdotal stuff becomes more than just one story that's not useful? Is it?
Well, we can base our work on anecdotal data, but it will never, in a modern society, never make a compound become a drug just on the basis of anecdotal evidence. One needs clinical trials. Without the clinical trials, a new drug will not be accepted, not by the FDA. It will still be an extract.
And anecdotal cases is also a problem that even if it was successful, this patient don't know which type of cannabis they use, if it was high THC or high CBD and so on. And I won't return to this, what was not fulfilled. Professor Mechoulam already mentioned it, that 35 years ago they did legal research with a group from Brazil, and they found that epilepsy can be treated with CBD. Nothing happened. It was supposed to be anecdotal case or officially by the law illegal case that parents treated child with cannabidiol rich cannabis, and they found that it can treat this Dravet syndrome or this hard type of epilepsy. And then it was fulfilled what was idea already 35 years ago, and this was legal idea and was supposed to be illegal practice just to fulfill it.
I'll give you, and this is the last example. We have about 100 autoimmune diseases. About 10 of them are very central autoimmune diseases. Diabetes type 1, rheumatoid arthritis, many other diseases are autoimmune diseases. Our body attacks itself. And most definitely, cannabidiol has been found to act very positively in autoimmune diseases. As a matter of fact, a group here at the Beilinson Hospital looked at something that is more or less like an autoimmune disease. In many cancer patients, one has to exchange part of the body, the bone marrow, with bone marrow from outside. But the body doesn't like bone marrow from the outside, and it attacks the bone marrow, the new bone marrow, and the new bone marrow attacks the body, and the patient is sick. It has to be done because there is nothing else that can be done with these cancer patients. But many of them are sick, and this is called graft versus host disease, which is an autoimmune disease more or less. Well, a group at Beilinson thought, I was a little bit involved with them, a group at Beilinson Hospital thought that maybe, as cannabidiol is an autoimmune disease drug, let's give them cannabidiol. They gave them cannabidiol, and the results were outstanding. It definitely helps in graft versus host disease. So a company has taken up now this particular information by the Beilinson Hospital, and they are developing cannabidiol as a drug in the case of graft versus host disease. So chances are that we'll have a cannabidiol as a drug, hopefully again, within the next 3, 4, 5 years. In this particular case, cancer being treated after bone marrow with cannabidiol.
Okay, that was great. Thank you.
You're most welcome. Okay.